Hello students, welcome to the EPG Pathshala. I am Sanket Borad, Scientist, Dairy Technology Division, National Dairy Research Institute, Karnal, Haryana. Today we will discuss the module Technology of Bakery and Confectionery under paper Technology of Caramel, Toffee and Fudge. As we know, caramel, toffee and fudge are basically sugar confectionery. They are almost made up of similar ingredients, but still, because of certain processing parameters, there is a drastic difference in the quality of caramel, toffee and fudge. The textural, sensorial as well as shelf life of all these products are affected because of its processing, since the ingredients from which these sugar confectionaries are made are almost similar. So in this context, how we process these sugar confectionaries are really very important. So in today's module, we will make you familiar with the technology of caramel, toffee and fudge manufacturing. The other objective of this module is to understand the effect of processing on the quality parameter of caramel, toffee and fudge. Initially, candies of fruits and nuts dipped in honey were prepared by Arabs and Chinese. But during the Middle Ages, refined sugar of any kind was very expensive and a rare treat. By the early 19th century, Americans used sugar beet juice to make new candies, and so caramels were invented in the United States of America in 19th century. Originally, the production of caramels occurred using copper pots over direct gas flames. Watched carefully by the master confectioners, who used a candy thermometer to monitor the temperature and poured out the cooling caramel batch onto a marble slab or water-cooled table and scored it into squares. Caramel can be described as a soft glasses that are viscous in nature and contain a dispersion of milk and an emulsion of fat. Caramel is a particularly popular and widely consumed confection that produces image of delicious, chewy treat in the mind of consumer. Caramel can be found in the range of textures, colors, flavors, and the products may be consumed alone or in a combination with chocolate, marshmallow, nut, and other inclusions. The properties of individual caramels are dictated by ingredients, formulation, and processing. The best caramels are sweet and just a little bit chewy. Caramel manufacturers use the term short to characterize a caramel that is too soft, perhaps too moist, or long for caramel that is quite chewy. Caramels are softer can be because they have been cooked soft to a lower temperature that are viscous in hard nature, candies, and which is approximately dispersion of 118 degrees Celsius emulsion of to form a ball stage. Caramel and contains is a particular popular and widely consumed confection because of this soft texture. Image caramel can be extruded at lower temperature in the mind of which consumer. Can be molded and caramel can be a variety of other candies textures or candy bars to add flavors and products and may be consumed alone agent or in the combination of heat chocolate on the milk solids marshmallow in conjugation with sugar ingredients other imparts a typical caramel flavor of these individual caramels essentially dictated by ingredients formulation the Maillard Browning reaction. The best caramels are sweet caramelization and process. Just a little sugar bit syrups are cooked. Caramel manufacturers proper moisture level the term added to the fat characterize a caramel heated that is followed by perhaps caramelization too moist to develop a typical long characteristic for caramel that is quite chewy and distinguishing caramels are softer because in they have browning kettle to a lower temperature Then
Different
hard
raw
candies,
materials are
which is
used
depending
approximately
on the
118
manufacturing
degrees
and type
Celsius
of
to
caramel
form a
under
ball stage
production.
and
However,
contains more
the most
moisture.
frequently made caramel, a vanilla caramel, contains many ingredients if it is a mass produced. The ingredients include milk, sometimes sweetened condensed milk, corn syrup, sugar, oil, whey, calcium carbonate, salt, flavor, and butter. Another type of fat, such as vegetable oil, can also be used. Molasses and cornstarch are also sometimes added as an ingredient. Milk is an
Different raw
essential
materials are
ingredient
used to
depending on
distinguish
the
the caramel
manufacturing
from hard
and type
candy,
of
and
caramel
it is the
under
milk solids.
production
Different
that
raw
change. However,
materials are
chemically
used
most
to produce
depending
caramel.
on the manufacturing and
A
type
vanilla
of
caramel
caramel
blends
contains
additional
many
sweetness to
ingredients.
the candy
However,
batch,
if it is a
but
mass produced,
also
made
protects
caramel,
the
the
mixture
ingredients
from
include
vanilla
becoming cream,
caramel,
sometimes sweetened
which would
many
indicate
ingredients,
there
corn
is a
syrup, if it
too
is a
much
mass
sugar
produced,
in the batch.
the
Oil,
ingredients
because
include milk,
vanillus will
sometimes
ruin
calcium
the batch
carbonate,
of
milk,
caramel.
salt, corn syrup, flavor,
Corn syrup
and
also
butter.
lends body to
Oil,
the slurry.
another type of
Whey,
fat
at least
such as
calcium
vegetable
carbonate
oil,
added to
salt,
the
can
mixture
also
as
be
well.
used, and butter.
Butter
Molasses
is
and
another type of
cornstarch
fat
are
only
also such as
sometimes
vegetable
added
oil
by
as an
the
ingredient.
caramel
Can also be
makers
used.
milk
As is an
is no
essential
ideal
and
superior
cornstarch
ingredient,
are
but
also
distinguish the
sometimes
caramel
added
to be
hard
as a
candy
very
and
expensive
it
for
is the
mass
milk
production
is an
that
essential
change
so
chemically
other
to
fats
produce
are
distinguish
added
the caramel
along
from
with
hard
a
candy,
fairly
and it
small
is the milk
amount of
solids
butter.
that change
A
chemically
maple
to
caramel
produce
or
caramel.
other flavored caramels are produced. The ingredients vary accordingly. Depending upon the batch size, all the calculated amount of ingredients are weighed using batching and dissolving machine, which is exclusively made for manufacture of caramel. The liquid and the dry ingredients are loaded into the machine. Then these ingredients are weighed with great precision by computer into a weighing tank, which may be on the upper side of equipment. These ingredients are mixed using propellers in this weighing tank. After blending, this milky slurry drops automatically to the lower mixing and dissolving tank, where steam heats brings mixture to the predetermined temperature. In the mixed tank, gear driven agitation equipment dissolves the ingredients thoroughly and uniformly. The scrape surface heat exchangers scrapes skim milk along with bottom and sides where burnt protein solids have tendency to accumulate. These burnt solids are redistributed and mixed back into the slurry to ensure that whole mixture is a homogeneous batch. The heated slurry is allowed to evaporate water in the scrap surface heat exchanger. The syrup leaving the scrap surface heat exchanger is forced through a small jacketed space where the presence of steam force evaporation is carried out. The caramelization is carried out at as high as 115 degrees Celsius temperature. The process of heating corresponds to the various technical terms. During heating to 110 to 112 degrees Celsius, solution thickens into a syrup threads when you pull spoon out, and this stage is called a thread stage. This caramel candy now has to be cooled down. The system utilizes a cooling wheel. The caramel is water cooled on the outside surface of large wheel. Then caramel is laid in a film about 1/8 inch, that is 3.2 mm thick on this wheel. The wheel completes half turn and the caramel comes off wheel, becomes solid and of consistency so that candy may be cut, packed and stored. Quality control. The machinery involved in the process of candy making is automated. The making of caramels requires precise measurement of ingredients, since too much sugar makes the candy grainy and makes it an inferior product. If there is too much moisture in the product, caramel will be too gooey in a warm weather. Too little moisture and cooked to high heat and a long or chewy caramel is a result. So, the machinery must be carefully checked and calibrated for accuracy in the mixing and weighing of material. Insufficient mixing while cooking may lead to either too predominant taste, grittiness due to the protein not being evenly dispersed, or oily taste if fat was not fully emulsified. The type of cooker used may greatly affect the product made relatively to shear rate, cooling time, and mixing efficiency. Temperature controls must be extraordinarily accurate since just a few degrees can affect the consistency of caramel. Human operators on the floor use their eyes and hands in order to maintain quality. Master caramel makers are essential to the production of caramels made in smaller batches at a time. Their experience can detect any slight variation that may result in an inferior batch just by the look, smell, and the feel of the batch. As with all good manufacturer, quality of all consumable ingredients must be checked for quality. Corn syrup must be of high quality needed for this candy manufacturing. All other ingredients must be tested for quality as represented by the supplier. It will be obvious that judgment and consistency of product quality depended totally on the skill of confectioner. The origin of the word toffee seems to be lost in time, although it might be derived from word taffy, a dialect word for sticky. The development of toffee is regarded as an important aspect as it was said to combine the attributes of soft American caramel with English hard toffee. The resulting chewy product had an advantage that it could be sold all around the world without refrigeration. Because of this history, in the UK at least, toffee and caramel seems to be used interchangeably, and toffee is used to refer the product ranging from viscous liquid to hard sugar glasses. So technically, toffee are high boiled products containing brown sugar, glucose sugar, or invert sugar and fat, usually butter. These products have moisture level less than 5%. Most toffees are chewable rather than glassy. The basic ingredients used in the production of toffee include sugar, that is sucrose, glucose syrup, milk protein, fat, salt, water, and other additives like color, flavor, etc. Structure of toffee. Toffee is an emulsion of fat in complex aqueous system. It is a mixture of sugars, water, and protein which is resistant to crystallization. Toffees have numbers of textural characteristics. Hardness is a function of moisture content. Chewiness and toughness on eating are related to the molecular weight of carbohydrates, and body is a function of quantity and state of milk protein, which is mainly affected by quantity and degree of emulsification along with hardness of fat. All these characteristics of different ingredients affecting the eating characteristics of toffee, and by varying the ratio of ingredients and alternative ingredients used leads to give a desired texture of toffee. Formulation depends on the requirement of toffee, which may be wrapping as a sweet for depositing into chocolate shell or layering onto other confectionery products. In general, balanced recipe contains 3 parts of sugar, 5 parts of glucose syrup, 3 parts of sweetened condensed milk, and 1 part of fat. For wrapped toffee, the ratio of sugar to non-crystallized sugar should be 1.1 is to 1. For deposit products, milk protein used up to 2% acceptable. Above this may create problems. For deposit into shells, low viscosities at low temperatures are required and thinning with syrup of low molecular weight sugars may be necessary. Let us understand the technology of toffee making. Toffee can be made using equipment ranging from small ordinary saucepan for batch process to a large continuous plant. The processes carried out for toffee making are fundamentally similar to those other sugar-based confectionery products. First of all, solid sugars are dissolved in water or mixture of water and glucose syrup. On the other hand, fat and skim milk solids are added into the dissolved sugar or glucose syrup, which makes a uniform emulsion. The emulsion is then cooked to achieve the final water content. The final water content is controlled by measuring the boiling point of product or a mixture. If boiling point is 118 to 132 degrees Celsius, the end product is called regular toffee. But if the temperature of boiling is elevated, that is at 146 to 154 degrees Celsius, the moisture evaporation will be to a greater extent and it will lead to harder texture of toffee, and so the end product is called hard toffee. The product made on the continuous plant often has a different texture and taste to the original product. Other relates to the rheological changes that occur during the cooking process. The finished toffee has to be shaped in some way. Toffee is normally run into trays, cut into the slabs, or used as a component of other confectionery. There are 3 processes used for shaping toffee for individual twist wrapping. These processes include swap process, cut and wrap processing, and depositing. In slab process, the toffee, liquid toffee is poured preferably manually onto the water-cooled slab coated with release agent. In case of cut and wrap process, the toffee is cooled and fed to the rollers known as a batch rollers that shapes the mass into a cone and then into a rope. The product is cut with rotating knife and the pieces are fed onto a wrapping paper and a twist wrap. This is the most modern process of 3 called depositing process. The soft caramels are deposited into a starch mold or chocolate cells which are later sealed by adding a chocolate bake. The high technology method is to deposit toffee into rubber molds. Toffees are mostly packed in individual wrap or can be made from waxed paper, aluminum foil, or cellulose film, or combination of any of these. In most cases, toffees will be wrapped by hand, but for higher production, semi-automatic wrapping machines are available at industrial level. For further protection, the individually wrapped sweets may be packed into a heat-sealed polythene bags. The packed toffees are mostly stored under the ambient condition of temperature and humidity. Fudge Fudge is a grain product, also called a fondant containing milk protein and fat, often a butter fat, which is having a characteristic flavor of caramel or toffee. Fudge can also be defined as a hybrid confection, a cross between caramel and cream. Perhaps the first fudge was made by someone accidentally graining a batch of caramel. Fudge have wide range of texture, from hard snappy texture of traditional Scottish cut tablet with its very high sugar content to soft tender texture of chocolate coated starch molded units. Often an egg whisk is added to give a light fluffy texture similar to a soft cream. Since the fudge is no different than other sugar confectionery, the main ingredient used in the production of fudge is sugar, that is sucrose. The basic ingredients of fudge are as sugar, glucose syrup, milk proteins, fat, salts, and water content. Since the composition of fudge vary from region to region, it roughly comprises of 17 to 25% of reducing sugar solids, whereas sucrose impart 45 to 55% of its proportion to the chemical composition of fudge. Fat and other milk solids makes up almost 20% of its component, and remaining 7 to 10% moisture content makes up the fudge. The basic unit operations in the fudge manufacturing are pre-mixing, emulsification, cooking, caramelization, followed by cooling, graining, and forming. All the ingredients such as sugar, glucose syrup, milk solids, fat, and water, if required, along with salt, are blended. Ideally, the fat, milk, and glucose should be emulsified before the sugar is added. The reason being to disperse the fat into aqueous syrup to prevent it coating with sugar and retarding the solution. The emulsification is usually achieved in a high shear mixing stage between pre-mixing and cooking for typically 10 to 20 minutes while maintaining a temperature of 70 to 80 degrees Celsius. The emulsification of ingredients is carried out with the stirrers on a high speed. Ultrasonic homogenizers can also be used for the emulsification. Adequate emulsification is essential to optimize the flavor and to prevent fat separation during processing or storage. The emulsified batch is cooked with constant scraping to final temperature of 116 degrees Celsius, which is required to give the final moisture content to the product. During cooking, the batch will caramelize and develop a characteristic flavor and color. Caramelization is time and temperature dependent chemical reaction, and typical cooking time 20 minutes is required for the caramelization. Flavors are usually added at the end of cooking. Under batch processing conditions, the degree of caramelization is affected by quantity of protein, the quantity and types of reducing sugar, and time taken to reach the final boiling temperature. There have been several different methods developed to cook and caramelize continuously. Say for example, thin film or scrape surface cooker in which heat transfer rates are very high and evaporation occurs so rapidly that caramelization has no time to develop. Plate heat exchangers for compactness and absence of moving part. Capacity can be varied while dissolving and cooking. The sections can be part of same plate assembly. So, at the end of cooking, butter may be added if required, either in excess fondant added to bring the temperature below 105 degrees Celsius. The batch can be cooled by passing water through the pine jacket. Next stage is seeding or graining. The grained structure of fudge can be produced by induced sugar crystallization. Use of fondant to provide seed crystal is almost universal. However, fondant crystal is destroyed in a hot batch, so cooling off the boil to about 105 degrees Celsius is required to ensure adequate crystal present when batch is poured. The most common method is by pouring onto a slab followed by cooling and drying off until crystallization has stabilized, followed by cutting. But fudge can be deposited into trays and molds. Alternatively, beating can be employed to control the process of crystallization and produce crystals of an uniform size. The fudge mass is poured onto the table, left to cool, and then beaten with a wood or metal beater. The grained product is followed forming step. Forming of finished product can be carried out by means of any of extruding or bar forming or depositing or filling into plastic or foil trays, cutting and wrapping, followed by stamping into desired different shapes. The final product must be packed before storage. A moisture-proof individual wrap of waxed paper, aluminum foil, and cellulose film. So, dear students, at the end, we can say that the technology of sugar confectionery are almost the same. There is only difference in the processing temperatures. The, all the products are made from sugar as a principal ingredients along with dairy ingredients and some minor ingredients. But the end product quality characteristics depends largely on the processing variables like time and temperature. The sugar confectionaries are processed at very high temperature, which leads to certain chemical reactions called caramelization and Maillard browning in them. These chemical reactions impart characteristics body, texture, color and flavor to the product depending upon the intensity of heat treatment, that is time temperature combination. Simply by varying the time and temperature of heating, we can categorize this product into caramel, toffee and fudge, and within the product you can also vary the type of product, say for example short and long toffee, etc. Thank you.